Let's look at another surface area calculation. Here we compute the area of a planar surface. The equation is z equals 6 minus 3x minus 2y, and of course we can think of z as just f of xy, and this is in the first octant. So r is not given directly, but we know that r is just the projection in the xy plane. So we can set z equal to 0 and then transpose. So if z is 0, transpose the negative 3x term and the negative 2y term to get this equation, which will define r. Now, in order to set this up in terms of a representation that we can use in a double integral, we can just set y equal to 0, and we'll get that x will run from 0 to 2. And then we can basically just solve for y in terms of x, and x will now run from 0 to 6 minus 3x divided by 2. And of course, if you like, you can just simplify a little bit and get 3 minus 3 halves x. Not required, but can possibly help us out in the future. So again, remember, the computation of r has to do with how the problem is set up and where they're asking you to do the computation. Now, of course, in order to do the area of the surface, when we're given the Cartesian expression, we need the partials. So we're going to take the x partial of f, we're going to get negative 3, and we're going to take the y partial of f, and we're going to get negative 2. And then, of course, the expression 1 plus fx squared plus fy squared will be 1 plus 9 plus 4. And that'll give us 14. So that's constant, so that makes for an easy integral. So now to find the area of S, we simply integrate with our limits based upon r, the function square root of 14. Of course, this will come outside, that is, we can factor the square root of 14, and then of course we just have y between the two limits. Of course, the lower limit giving us 0, we end up with 3 minus 3 halves x. Now we integrate with respect to x. So this integral is really simple. Of course, here will give us 3x, and add 1 divided by the new power, we'll get a minus 3 over 4x squared, and evaluate between 0 and 2. Now, of course, the evaluation at 0 gives us 0, but evaluation at 2 will give us a 6. And of course, the 2 here will give us a negative 3/4 times the 4. The 4 is absorbed. We get 6 minus 3, which is 3. So we get an area of the surface of 3 times the square root of 14. Be sure to take stock with this problem. It exercises some really nice techniques. And we are done.